Hello, my History 125 students. This is Professor Collins for Week 7 video to try to go over things that we, talked about Week 6, what Week seven's themes are, and your Week 7 assignment. Yes, I am wearing glasses today because I am middle-aged, and occasionally middle-aged men can need to wear their reading glasses in order to actually see a little bit better. Especially when middle-aged men like me have done as much reading as I have the last 30 or 35 years of my life. So there's that. Anyway, um, in general, where you guys are after the first 6 weeks, most of you are in really good position to finish this class strong. You are. The last 2 weeks, particularly week 6, you've done really, really well with the discussions, with discussing how science and technology, um, breakthroughs, ideas, technological changes have led not always for the better for folks. Reinforcing the theme that progress is not linear. You don't just keep building and things just get better and better for everybody just because there's a new piece of technology out or new scientific method being used or new scientific discovery that people want to implement in the policy. Partly because human beings are biased. The only criticism I have from any of the discussions over the last 2 weeks is this idea that somehow scientists, historians, and other people creating new technologies, new knowledge, etc., have to be unbiased in order to do that. No, they don't. We're human beings. Absolutely do not have to be completely 100% objective. We're not robots. It's not about objectivity. It's about fairness. It's about truth. It's about pursuing fairness and truth through questions that that you're not working backwards from in order to answer. In other words, you think you already know the answer, and you're working backwards from to prove that your answer is the right one, right? And even that's not 100% true, because if you find something that contradicts what you think the answer is, then you report it. That's what you're supposed to do, right? That's about fairness and truth, not just hide it under the rug like the Nazis did, like eugenicists have and still do, because eugenicists are still around, that sort of thing. So, other than that minor point, you guys did a good job, and you've done really well the last few weeks. Now, this week, there are two themes around the week 7 readings that we should talk about real quick. And there's also your assignment that is due at the end of this week that we'll talk about really, really quickly. I'll start with the assignment. I think that's the best way to start. For those of you who did the week 4 assignment and actually figured out what your topic was, this should be a breeze. I already sent out an email to everyone around what a sample of a PowerPoint slide and the PowerPoint project presentation that was put together, proposal that was put together for a previous iteration of History 125 that I taught this summer, and that one, the one that you have, was an A. Right? It has a cover page. It has a page that is a summary of the proposal, basically executive summary, 250 words. It has a page that basically breaks down the history of the technology, or as the case may be, the history of the science behind whatever it is that you're trying to propose. The pros and cons pages that deals with the pros of implementing this in terms of policy or technology or science, and the cons around doing so. And then finally, um, there is a set of sources listed at the end on the final page. That should take up 7 total slides, maybe even 8. So between 7 and 8 slides total max. The hardest part probably is figuring out how to use PowerPoint or Google Slides. The rest of it, it depends. If you want to record yourself, if you want to put pictures in, if you want to do specialized designs, if you want to bring in a TED talk that someone did on this topic, um, if you want to play music, right? Whatever it is that be a little creative here. This is a place where you can be somewhat creative and not just do bullet points throughout. You know, it's not going to, you know, it can improve your grades some, but fundamentally, if you don't do those fundamentals I just talked about, you can put all the bells and whistles you want in. I have to still go by the rubric that requires you to do the things I just listed, So, but other than that, if you want to be creative, this is a good opportunity to be. Unfortunately, you don't get to actually present the proposal. You're just providing it, right? But if we were to do a full-fledged version of this course, you would conceivably be presenting this as well. So there's that. Anyway, maybe that's for future iterations of this course, maybe a year or two from now. But that's not up to me. That's up to a committee of UMUC professors. It usually doesn't have me on it. So we'll see. Anyway, week 7. Week 7 is basically about two themes, right? The main theme is about Tesla and Thomas Edison, who are essentially co-credited not with the discovery of electricity, right? Electricity is a Greek term. People have understood the concept of electricity in various cultures around the world going back approximately anywhere between 2 and 3,000 years ago. It's not about discovering electricity. It's about harnessing it. The ability to use technology and science to actually harness a basic physical property of the universe and being able to use it to power our lives. That's what this is about. The period after 1870 is really the period where people figure out how to harness electricity and use it for everything from battery storage to lights to recording sound and video like you're hearing me do now. All of this is about electricity. The light you have is based off the basic properties of understanding the exchange of photons and electrons between atoms. That's basically what we're talking about here. Even our understanding of stars, of the sun, is based on understanding the basic properties of electricity, whether through nuclear fusion or electroplasma energy, or through being able to use a carbon filament to light a light. It's that simple. Um, and how this gets us out of essentially this long, long, long period of human history where humans, if they wanted light at all at night, it was by fire, whether it's through an oil lamp or through burning wood. That's the way we got light for most of our history until basically 1877 or 1881 in Buffalo, or 1892 or 93 at the Chicago World's Fair. The fight between Tesla and Edison is over alternating current using power transformers and other methods to step down electrical current, and direct current, where you basically had to plug your whatever your device was directly into a source in order to get that electricity. And then, in fact, Edison's recommendation of direct current was more dangerous, and Tesla's was actually the steadier way to go. Tesla won the battle, lost the war, because ultimately Edison had the backing of folks like J.P. Morgan to continue to do his work. The theme that's underlying that theme of these great men with their singular inventions is the fact that they weren't, as great as these men were, they were not doing this work by themselves. They had hired other people to find the materials necessary to build transformers to step down electricity in the case of alternating current. George Westinghouse was a backer of that, but there was a whole group of people who worked with Tesla to help him create alternating current devices. For Edison, Edison can't even find a filament without some random black guy who happened to have the right carbon filament for him to continually run the light bulb for, 75 hours, right? Or for 15 hours, as opposed to the 1 or 2 hours that most people were able to get prior to 1876. Edison doesn't deserve all the credit for his inventions, and even though he comes up with thousands of patents and thousands of ideas, other people help them with those ideas, right? There's nothing new under the sun here in terms of this. This great singular guy, creating everything from point A to point Z in terms of a particular invention is a creation of the late 19th and early 20th century. And Edison is very much a part of that image, but that image is false. It's a myth. And, even though some of you will probably take all of what I'm saying with a grain of salt, what do I know? I'm just a historian, right? The truth is, that's how most inventions happen. Um, Menlo Park, the Wizard of Menlo Park was not by himself. He worked with a whole group of folks that he hired to help him with all of these questions around recording sound, recording video, the first motion picture, 1888, recording sound with a phonograph in 1878. All of those questions. So there's that. And then there's Einstein and Einstein's theory of relativity and all those ideas about equals mc squared, which is energy, which is this big E, right? Equals mass of whatever, times the speed of light squared, right? So just, that is the equation that leads to the building of nuclear weapons, for instance, and also nuclear power plants. And that's all to point out, once again, and by the way, E equals mc squared is based on Newtonian equations and other scientists in the 17th, 18th, and 19th century who worked on the problems of kinetic energy. One of the things that you can pull from kinetic energy is the idea of how to harness electricity. So it all relates back to electricity some way, shape, or form, right? All nuclear bombs are is uncontrolled electroplasmatic energy turned into the form of a gigantic mushroom cloud that for a split second heats up to something like 15 million degrees Fahrenheit and for can stay for upwards of a couple of minutes at 5,000 degrees centigrade, enough to melt most metals. Combined with the pushing of billions of tons of air down on the entire cities or entire sections of country, you can pretty much destroy anything you want. So that's to just give you some idea about what we're talking about here in terms of progress versus danger, lethal danger, world destroying and civilization destroying danger, all based on the use of the big and the very, very small. From the cosmic to the quantum, which and electricity is in the latter category in terms of the quantum energy that can have actually cosmic effects, right? So really, really briefly, before I forget, you also want to think this week about that even though there's a lot of progress been made in terms of households and household appliances, in terms of electricity and having electricity around the world, most electricity doesn't make its way around the world for the vast majority of people until basically after World War II. Why? Because the first applications of all of these new discoveries, like the theory of relativity, like E equals mc squared, even electricity, is invested in military, right? So everything from tanks and motorcycles and machine guns and high-powered rifles and submarines that can stay underwater for hours at a time, and battleships and aircraft carriers. All of that are electrically based machines that might run on fuel, but you still need batteries for them. And all of those jumps in technological change, even airplanes, you know, was primarily because people, I should say empires, wanted to wage war. World Wars One and Two are based on these modern technologies. Those two wars combined, something like 100 million people died in those two wars combined. That's a third of the U.S. population in 2019. Just wipe out a third of the population in a matter of like a decade. You would think that there was a major pandemic going on if that were the case. No, war is a pandemic unto itself. And, you know, and while military is necessary, fighting world wars isn't, right? And that can't be counted as progress. Can't be counted as progress when the most advanced nations on earth use that progress in order to fight war, to kill millions and millions of people, despite what everyone thinks. So please think about that and not just talk about progress is great and wonderful all the time in your week 7 discussions as well. So that's it. I'll talk to you one more time in the next week.